Good morning. I hope you guys are all doing good. Have waves all behind you and did well on the 3 week test. And now we're going to start a new topic, and that is electrostatics. And so, just to kind of first tie it in with something you've experienced, you guys ever rubbed a balloon with your hair and then, touched it to the wall and it sticks to the wall? Or your sweater made crackling noises when you took it off, or sometimes you even saw sparks, electric shock from a doorknob, especially if you've been dragging your feet. And of course, you've seen lightning. And these things all happen because there's a buildup of electrical charge. And electrical charges are the same type. They don't like being near each other. Um, and so they discharge, and we'll look and see what's happening here. So we're going to be looking at those phenomena in more detail. So what is this charge thing? If you go back, I'm sure you learned back in chemistry about atoms, and the only thing that really carries a positive electrical charge within the scope of what we're studying is a proton. And there's nothing else that has a positive charge. I kind of lied because there are other particles, but not at the energies that we're working on. And then there is the electron that carries a negative charge. And he's the only guy that we'll consider that carries an electrical charge. And so if there are electrons, you're going to have negative charges. If there's protons, you're going to have a positive charges. And those are the only things that carry charge. Now, all matter is made up of protons and electrons, and not to forget about our neutron buddies. They come along too, but we know that they don't carry any charge at all. They just carry some mass, right? Okay, so when we start to look at atoms, this you can see that they're really, really tiny. They're spaced far apart. Um, compared to their sizes. And in the air in your classroom, there are about that many. I won't even try to read it. So let's say we have threes, thousands, millions, billion, trillion, quadrillion, quintillion, hexillion, septillion, octillion, 1.5 octillion atoms. Yikes. And of course, atoms are made up of neutral neutrons, positively charged protons, and negatively charged electrons. I hope you guys are taking notes. So we can positively charge something or negatively charge an object. So let's say I have a plastic rod in my hand or a little pen here, and I want to charge it. The way I would do that is the first thing I could do is I could rub it with something and either add electrons to it, which would make it negatively charged, or take electrons away from it. And I hope you understand that if I remove electrons, because most atoms carry the same number of protons as electrons, right? They're neutrally charged. Any regular old atom you look at by itself is just negatively charged. And so if you um, take a electron out of that system, you're going to end up with more positive charges. And so that's how you create positive charges. I want it to be really clear in your heads that the protons don't move. Okay, they're kind of stuck. They're the centers. The electrons are those loose guys on top, especially the ones that are far away from the nucleus, and they can be easily taken out. So here you go. The outermost electrons of most atoms are bound loosely and can easily be dislodged. Now we'll see the difference between conductors